Redflow Energy Storage.
Hi, I'm John Lindsay and I'm a director of Redflow. In a former life, I was the Chief Technology Officer of a telecommunication company, and I was responsible for batteries at remote telecommunication facilities, and managing them was actually quite difficult. Recently, Simon Hackett showed me the battery management system for the ZBMs, and I was really excited at how that solved quite a lot of the problems that we used to have looking after those batteries previously.
Unlike traditional electrochemical batteries, the Redflow Zinc Bromine Module, or ZBM, has an onboard manager that controls whether each ZBM can be charged, discharged, put to sleep, or woken up. Each group of ZBMs can have a battery management system, or BMS, which coordinates the operation of the ZBMs and communicates with the battery charger and load via an interface called CAN bus. The Redflow BMS connects to a Redflow cloud service, which securely monitors the status of every ZBM and securely allows the onboard software or firmware to be updated, just like your computer gets updated. So your ZBM will probably be smarter in the future. As a former telco and ISP Chief Technology Officer, the Redflow BMS really excites me because the power systems used for mobile base stations and wireless ISP sites are usually very simple, a battery charger, and the equipment is often connected directly to the batteries. Sometimes the first time you discover a lithium or lead acid cell has failed is when the equipment at the site stops working after the sun goes down or the mains power fails. If I log into the Redflow BMS, we can see the status of Simon Hackett's ZBMs in his large-scale battery at base 64. We can see the overall charging and discharging activity of the past 24 hours. It's a very overcast winter day in Adelaide. We can see a summary of the entire bank of ZBMs, which is the view the rest of the power system, for instance, your battery inverter, sees via that CAN bus interface. For each individual ZBM, you can see if it's enabled for charging, or for discharging, or for both. You can also see if the ZBM has entered its periodic maintenance cycle, where any surplus charge is extracted and stored in the other ZBMs that are available for charging. It's a very cold day in Adelaide, and if I move to another bank, you can see a ZBM here as warning that it's approaching the minimum operating temperature as it approaches the final stage of maintenance. Again, I find this really exciting. With traditional battery banks of cells, the entire battery is charged, then floats, and eventually discharges when needed. Within a set of ZBMs, some can be charging, some discharging, and some in standby, either charged or discharged depending on your application. This means you can reserve capacity to act like a standby generator while efficiently running your site on solar or wind power. You can also have spare batteries that are ready to use, but are almost completely shut down so their pumps and fans are not running. Perhaps most importantly, the BMS can use the standby mode to hide the maintenance cycles of your ZBMs, which lets an array of ZBMs operate just like a lithium or lead acid battery bank, but with more flexibility, availability, and operating life. The Redflow BMS turns a set of ZBMs into an energy storage appliance. The BMS also has graphs and logs, so you can see the performance of your ZBMs over time. Thank you for your time watching this video. I hope you learned something about how the Redflow BMS turns ZBMs into an energy storage appliance. Don't forget to subscribe to the Redflow channel on YouTube.
Redflow Energy Storage.